All right, so the first example is basically from a coordinate. I want to show you, we've been looking at a lot about coordinates on our unit circle. So let's say we had the point 3, 4. Let's say that was a coordinate, and they said find the 6 trig functions of that coordinate. Well, you could do that if you can make a right triangle out of it. So you would draw a graph and maybe go over 3 and up 4. So this right up here would be the point 3, 4. You would connect it to the origin to get our angle. The x value is the bottom of the triangle. The y value is the top. Those are the two sides, 3 and 4. There's my angle, theta. And if you notice, that's the same triangle that we have down here, over 3 and up 4. So basically, you could have made this yellow triangle from a coordinate, from a point on a graph, 3, 4. So if you ever see that point, then you know that you can take that coordinate and you can draw it on an xy axis, and then you can find all the trig functions from that triangle. Because you're always going to know two sides from a coordinate. It's going to give you an x side and it's going to give you a y side. And you can find the third side because we know Pythagorean theorem from chapter 9. 3 squared plus 4 squared equals c squared. If you solve this, you'll end up with c is 5. So this side right here is a 5. Now the reason that we need that 5 is so that we can find all of the trig functions. We need to use our SO and our CA and our TOA to get the 6 functions. So we want to find, it says find the 6 trig functions for theta. Theta is the angle next to the origin down here, because this is where it was up here on the origin. So if I want to find the sine of theta, then I'm going to look at my opposite side, and I'm going to look at my hypotenuse. So it's going to be 4/5. And the sine of theta is a fraction of 4/5. I can change it to a decimal of 0.8 if I wanted to, but I'm going to leave it as a fraction. Now I know cosecant, because we know that cosecant is reciprocal of sine, so I could just flip that over and you get 5/4. So your sine is 4/5, your cosecant then is 5/4. We now know the cosine of theta. You would follow the angle to its adjacent side, which is touching that angle, adjacent, and the hypotenuse is a 5, so it's 3/5. And that is reciprocal of secant. So you would flip that one over and you get 5/3. Now let me stop for a second just to remind you of a couple things that we did already. Notice how your sine is 4/5, which is a 0.8, and your cosine is a 3/5, which is a 0.6. Both of those are less than 1. But they're going to be greater than -1. They're going to be somewhere between -1 and +1 are all your sine and cosine values. We saw that on that little worksheet, or it was actually your little hyperdoc that you were looking at all sines and cosines, and it was always between -1, +1. Sine will always be between those, and so will cosine. But when you flip it around and do secant and cosecant, they're going to be above a 1 and below a -1. If you look at your unit circle and the chart on the back, if you look at these last two columns, you will not find one of them that would ever start with a 0 point something, because it's the reciprocal of the ones that start with a 0 point something. It's going to be ones that are going to be bigger than 1 or less than -1. These -2s, those are below the -1. So your sine and cosine will always be between +1 up top and -1 on the bottom, and it will go up and down in that area. But the cosecant and secant will be above and below those. They'll never be in those areas because they're reciprocals of each other. The tangent is going to be the opposite 4 over the adjacent 3, so that's 4/3. And that's reciprocal of cotangent. So that's just going to be 3/4. So there is how you would do one. If they give you a coordinate, you can draw a triangle, which will then allow you to get the 6 trig functions. Anytime you got a coordinate, you have your x and your y value. You've got the adjacent side and you've got the opposite side of a triangle. Every coordinate gives you those two pieces. Then they want you to slide into reviewing the two special triangles. They want you to see the 45-degree angles. So if we've got two angles that are both 45 degrees, that means we have to have two sides that are both equal. So that's what happens in every 45, 45, 90. You'll have two equal legs. And so if you, and then of course radical 2, here's our hypotenuse. They just decided to make the legs 1. That means the hypotenuse would be a 1 times a radical 2. You make your leg and times it by radical 2 to get your hypotenuse. That was our little formula. But if we want to get the sine of that angle, we would do the opposite side, which is a 1. Whether you do either 45 you're across from, it's going to be a 1. And your hypotenuse is going to be a radical 2, which we would need to fix. We can't put it on the bottom. So you're going to get radical 2 over 2, which is exactly what you see on your unit circle. This unit circle is like your reduced triangles. So if you look at 45 degrees, you're going to see the two radical 2 over 2's on that coordinate. They're both radical 2 over 2. The y value is sine, the x value is cosine, and both of them are going to be a radical 2 over 2 value. Because both of them are going to be, opposite would be a 1 and adjacent would be a 1. So you're going to do 1 over radical 2 for both of them. That's why when your hypotenuse was a 1, you actually get the radical 2 over 2's for the two sides. So if I had changed this hypotenuse to a 1, then these would be radical 2 over 2's is what they're saying. Okay? So I'm not going to put that now, but that's what they're saying. And then the tangent of any 45-degree angle is going to be the opposite over the adjacent, which is always going to be the same number on top and bottom. These could both be 10s. They could both be radical 2 over 2's. Either way, you'd have the same thing on top and bottom. It's going to always be a 1. Tangent theta always equals a 1 at 45 degrees, when theta is 45. So that's one of your special triangles. And again, you have this link on Classroom, so you can be following along with it. There's the other triangle, the 30, 60, 90 triangle. It's basically cutting an equilateral triangle in half, because this bottom down here would still be a 2, and you'd have all 3 2's around the outside of that triangle. If you bring down an altitude from that, that is actually the longer leg of our 30, 60, 90. Your shorter leg is down here at the bottom, and then you double that short leg, you get your hypotenuse, which is this side over here. Now what they want are the sine and cosine of the two acute angles. So let's look at that. They want sine of 60, and let's see what sine of 60 is. Here's my 60-degree angle there. Across from that would be the radical 3, and the hypotenuse is a 2. So we're looking at radical 3 over 2. They also want us to get the cosine of 60. Cosine of 60. Still have a 60 here. My adjacent is down here right below. It's touching. And the hypotenuse is still a 2. So it's going to be a 1 over a 2 for the cosine of 60. They want the sine of 30. So let's put sine of 30. And let's see, that's going to be up here as 30. So across from that would be the 1. And then you have your hypotenuse of 2. Notice those two are equal. Sine of 30, cosine of 60, the same. The last thing they want is the sine of, no, the cosine of 30 is what they want next. Okay, so cosine 30. We would do our adjacent to 30, which is the radical 3, and the hypotenuse of 2. Notice those two are the same. So what they're trying to show you in this little triangle here is that the sine of one angle is going to equal the cosine of its complementary angle. These are called complementary angles when they add up to 90. So when you see 90 minus theta, it really means that you're trying to find its complement. Remember, if you got one angle, how do you find its complement? You subtract it from 90. So if we know that we have a 60-degree angle, so we put that into theta, both places into theta, sine of 90 minus 60, what is 90 minus 60? 30 equals the cosine of 60. Doesn't the sine of 30 right here equal the cosine of 60? Yeah, so when you see this on your homework, if you see something that says 90 minus theta, and you say it says sine of 90 minus theta, what it's really asking you for is the cosine of theta. The sine of its complement is equal to that other angle. So we want it, sine of 90 minus theta means cosine of theta. If they say what's the tangent of 90 minus theta, they're really asking for cotangent because they're complementary. If they say find the cosine of 90 minus theta, they're looking for sine. And it works well. It works for secant and cosecant as well. And it's only because they add up to 90. If you remember from geometry, we had something like this. We had sine of 15 degrees would equal the cosine of 75 degrees. Because those two added up to 90 degrees, their sine was equal to their cosine. So that is just kind of what they're doing down here. But don't freak out if you see 90 minus theta. It just means it's asking for its complementary angle. That's all it means. Okay, so and you might see one, and we might be able to go over it tomorrow on there, but you don't get all freaked out if you don't know what that means. It just means it's complementary angle. Now let's go to example 4. There's a couple of identities. This is the identity part right here. And I don't know why that opened, so let's close it. Oh well. All right, so let's take a look at our identities. They're actually on your circle. Look at the underneath your circle part, you see all the identities down here. The top ones I've already actually given you. Maybe you didn't look at them, but we have looked at those. The sine is reciprocal of cosecant. So if you want to get sine, you could say it's equal to 1 over cosecant. Or you could switch that around and say that your cosecant is 1 over sine as well. So you can easily switch them around. Cosine and secant match up. So you see cosine is equal to 1 over secant, and secant is 1 over cosine. They're just the reciprocals of each other. Those are the reciprocal functions. We also looked at this one. We've seen this one on our unit circle. Bless you. I showed you that on the unit circle, if you take the cosine or sine and divide it by cosine, the coordinates, sine divided by cosine gave you the tangent. So that's a quotient identity. Tangent is sine divided by cosine. And we know that cotangent is reciprocal, so that's why cosine over sine would be the cotangent. So those are called quotient identities because you're dividing the trig functions. And then the last ones are all based on the Pythagorean theorem. We're going to dig into those a little bit more later, but they're just formulas that we're allowed to use. If we know sine, let's say we know sine, we can solve for cosine. That's going to come in handy on example 4. Because we know what the sine value is, we can plug it into this formula right there, and we can just get get cosine by itself and find cosine. So let's look at that. Here it tells us that the sine is 0.6. Okay, sine is 0.6. They want me to find cosine. And I look at this identity, and it's got a sine and a cosine in it. So let's take out the sine and put in 0.6. So it's going to be 0.6 squared because it was sine squared. So 0.6 squared plus cosine squared equals the 1. That's an identity. That's a Pythagorean identity. I can tell you right now, you're going to use that one the most. We're going to be using sine squared plus cosine squared equals 1 the most. And I'm going to prove to you when we get into chapter 2 that this identity works. But right now we're just using it because it's on our sheet, because we're allowed to. So 0.6 squared is 0.36 plus cosine squared equals 1. Now I want to get cosine by itself. So I need to subtract 0.36 on both sides. So I'm going to put 1.00. So I cancel that out. I get cosine squared equals 0.64. And if I square root both sides, you get cosine of x equals 0.8. Okay, so now I have my sine and I have my cosine, and they want me to find tan. So you go to this quotient identity and say, well, I can just divide those two and get tan. So my tangent is going to be my sine, which was 0.6, divided by my cosine, which was 0.8. If I multiply them both by 10, I get 6/8, and if I reduce that, I get 3/4. So your tangent is 3/4, and if we want to keep the same theme as decimals, it would actually be 0.75. So now you know your cosine is 0.8, you know your tangent is 0.75, and they gave you that the sine was 0.6. So you've got all three trig functions as decimals, just by using these identities. Now that is not the only way you could have solved it. Okay, that you could have drawn yourself a triangle. This sine is 0.6 really means that your opposite side is 0.6 and your hypotenuse is a 1. Because your sine represents opposite over hypotenuse, and if 0.6 is your sine, then you could say opposite over hypotenuse would be 0.6/1. You could have other things that would equal 0.6, like 3/5 or whatever, but we could say that the opposite side of my theta is 0.6 and the hypotenuse is 1. So I drew a triangle that had a theta in it. Okay, it had an opposite side of 0.6 and it had a hypotenuse of 1. And when we did the Pythagorean theorem, you would get 0.8 as your bottom side. And I could have found the same trig functions. Opposite over hypotenuse, adjacent over hypotenuse would be 0.8. Opposite over adjacent would be the 0.6 over the 0.8, which I did over here in the identities. There's the 0.6 over the 0.8. Just by doing the opposite and adjacent, you would have got the same too. So you could draw a triangle, you could use the identities. Right now, what they want you to practice are the identities. They want you to see if you can plug them in and find out how it works. So let's look at number 5 example. Okay, you could use a picture. Again, like I said, we could draw a triangle. Okay, but let's see if we can use the identities. And what they're giving us is that the tangent of theta equals a 3. And I'm going to make a fraction out of it because tangent means opposite over adjacent. That's why my picture has an opposite of 3 and an adjacent of 1. Because my tangent means opposite over adjacent. Now, if I want to find cotangent, letter A, cotangent of theta is 1 over the tangent of theta. That is a reciprocal identity. So if my tangent is 3, my cotangent is going to be the reciprocal of that, which is 1/3. So that's going to equal 1/3. So you've got your cotangent. It's just flipped over the tangent. You got your cotangent. That one's a quick one. Okay. Letter B is secant. Secant. We know tangent, and we know we want to find secant. So if I look at these identities again, we have one down and near the bottom again that has tangent and secant in it. 1 plus tangent squared equals secant squared. So I'm going to put 1 plus tangent squared equals secant squared. And I'm going to put in a 3 for tangent because tangent equals a 3. So 1 plus 3 squared equals secant squared. So that's going to be 1 plus 9. So that's going to be a 10 equals secant squared. If you square root both sides, you're going to get radical 10 as your secant. So there is your answer for secant, would just be radical 10. If we had looked at our picture your secant is reciprocal of your cosine. So it would actually be the hypotenuse over the adjacent is what your secant is. In this triangle up here, your hypotenuse is a radical 10 and your adjacent is a 1. So you would get the exact same answer that you got down here for secant. So either way, you could use the picture or you could use the identities and you'll get the right answer for secant. That's enough to get you through the first problems that I put on the board over there. So get those done tonight. We'll check those off tomorrow.